Sir, we are live now. Please start.
Thank you. Good evening, everybody. My name is Dr. Prasad Ramanathan. I am a senior director at Capgemini Technology Services India Limited in the AI/ML Center of Excellence within the Cloud and Infrastructure Services business unit. Today, we have a very interesting topic, which is usually not covered very much in colleges. And the topic that we will be covering today is what I call as ML engineering. And in order to understand what ML engineering is all about, we will first go through a series of slides to understand what exactly ML engineering is. And then Harsh Karry, who is also from Capgemini and is a machine learning specialist, will demonstrate how we can implement some of these concepts that we will cover in the next few minutes through a live demo and an actual demonstration that will help you understand what it takes to deploy a machine learning application and get it productionized. So that is the broad overview of what Harsh and I are going to cover today. Now, in the context of ML engineering, it is the intent, like I said, will be to talk about what ML engineering is all about and how it is a superset of machine learning, which is what most of us learn in colleges. I will briefly talk about some of the tools available from various cloud service providers in the context of machine learning, such as from Microsoft Azure ML and Google Cloud Platform, AWS SageMaker, and so on. And that is when I will hand over the baton to Harsh, who will then demonstrate how some tools like MLflow and Python Flask can be used to track the various machine learning experiments that we are conducting, how to deploy them, and how to productionize it as a web service. That is really the agenda for today. So with that background of what we are going to try and cover today, let us understand what are the various components of a real world production machine learning system. Now in this particular diagram, you will notice that the actual ML code represents less than 5% of the overall code that goes into a total production system that is leveraging machine learning. So what are the other aspects over and above the ML code, which is what most of us are trained to do as part of our data science program or machine learning degree or whatever the specialization that we get? We learn how to actually develop a model using various algorithms, supervised learning, unsupervised learning algorithms, reinforcement learning algorithm. But that part of it is less than 5% of the total code. So what happens in a real world production system over and above that model is what this diagram tries to depict. And clearly, in order to run this ML code in a real world situation, we need to collect data from the real world system and supply it to this ML code for it to do some predictions on it. So data collection is an important activity for which we may have to write code. Having collected the data, you have to verify that it meets the criteria that have been used in order to develop this model. So if your data had some pre-processing that was done, the same kind of pre-processing may have to be done and verified that the data is compliant with what you had in your ML code. Some features from this data have to be extracted and provided to this ML code. So these are some pre-processing activities that you may have done as part of your training activity and testing activity. But in the real-time situation, we have to do these in order to ensure that this ML code can be leveraged. Having got that data, now the other important thing is to ensure that we have the resources in the machine in order to execute all of this, and there has to be some kind of a API which will serve this particular machine learning model to the external world, so that if an external program were to ask for some prediction, then it can provide that data and it will receive some kind of a output from this model. So what is it that enables us to provide some kind of a API which will enable us to serve this machine learning model to the external world? Having got that API done, then you also need code that will analyze your outputs, verify that your outputs are still in line with the expectations of what is expected by the market. You have to monitor your infrastructure, you have to monitor your code, you have to monitor the model in order to ensure that in case of any changes that are substantially affecting the data, then correspondingly the model may have to go through some changes also. So the ability to monitor and make changes to your model is also important. And then ultimately, if you are able to make these changes without having to write code, but actually get these new models deployed only through some configuration parameters and things like that, that will further modularize the delivery of your production system and ensure that you don't have to keep writing code in order to deliver or rewriting code in order to make any changes here. So those are some key elements that one has to think about in the context of a real world production ML system. So given this kind of a picture, most of our college education enables us to learn a large amount of knowledge about a small piece of the real world system. So what are some things that we have to do in the context of ML engineering? That is what I want us to start appreciating. So ML engineering, like I said, is a superset of machine learning. Now, it is easy to visualize what exactly this means if we were to take an analogy of what software engineering is and what programming is. So many of us as engineers and BSc computer science or whatever be our program of learning, we would learn how to write code using a particular programming language, Java or C or C++ or Python or whatever it is. But that part of the programming element using that programming language is only one small element in the broad context of software engineering. What do we mean by software engineering? The ability to identify requirements, design the application, deliver the application, deploy it, and get the final output from this entire application. All of this typically goes through a series of stages, which is what we typically call as software engineering. Now, similarly, machine learning, the way we learn it in colleges, enables us to take certain data, apply certain machine learning algorithms, and be able to come up with a model which can then be used to predict the outcome given a new set of data. But that piece of it is only one element out of the broad scope of things related to ML engineering. So just like software engineering involves requirements, design, coding, deployment, and then monitoring and maintenance and things like that, same way ML engineering involves all of those stages that we saw or steps that we saw in the previous slide, and therefore it is a superset of machine learning as a field. Now, in this context, it is also important to realize that when we talk about software development, there is a new trend, a recent trend called Devops, where the development team and the operations teams have to play a close knit role in order to ensure that what is being developed by the developers is actually deployed by the operations team and it adds value to the business. So DevOps is one such field where the development team and the operations team are supposed to work closely with each other. And instead of having these as two separate teams, the current thought process is that these teams must be actually, or this work must be integrated within the same set of individuals, so that the same guy who is, or person who is actually developing the code can also deploy it, and vice versa. So there should be no separation between the dev team and the ops team. The same kind of a concept is what is being talked about in the context of machine learning, and we now talk about it as ML ops. So when we talk about ML engineering, we are now also bringing into this concept called ML ops, where the machine learning and the development and creation of the model and the actual deployment of the model are done by the same set of individuals, and they are not handed over from one team to another team, which will cause unnecessary delays. So the intent is that ML ops will be governed by all of these steps, where you have the development being done to do a bunch of experiments to develop the source code. Then you will do a continuous integration in order to establish the packages that need to be deployed as an automated pipeline. And then finally do some training in order to get the trained model. And you keep predicting whether, sorry, you keep monitoring this thing to figure out whether there is any changes to be done, and if so, you will involve further continuous training in order to get the refreshed trained model. So this is the example, or this is the broad flow for ML operations. Now if we were to expand on this further, what you will notice is that many cloud service providers provide tools which enable us as developers to achieve this development and deployment aspects in a much faster, quicker manner. What do I mean by that? As an example, if I were to take a look only at Azure machine learning as one tool that is being provided by Microsoft, you will notice that Azure machine learning provides you all of these functionalities, like creating reproducible machine learning pipelines, software environments, registering packages, deploying models, and so on and so forth. Each one of these capabilities is supported by the Azure machine learning platform, and we don't have to really install any of these tools in our laptop, desktop. These are all available on the cloud, and therefore there is a significant advantage of using machine learning as a service type of a platform itself in order to achieve many of these elements of ML ops. And before you start wondering, okay, why only Microsoft? No, that is not the case. It is not only with Microsoft. We can talk about it or see the same kind of a thing that is supported by Google. So Google has got TensorFlow Extended, which is an end-to-end platform for deploying the production pipelines, and they have a set of modules which again supports the entire ML ops pipeline completely, right from development to deployment to continuous monitoring and updations. So and while I don't have a specific slide related to Amazon, AWS SageMaker and the AWS machine learning tools also provide the same kind of a tool set which will enable us to achieve what we are talking about here. So in the context of machine learning or ML engineering, we are now going to spend a little bit of time trying to understand what exactly can we do with certain tools like MLflow, which enable us to capture what are those experiments that we are conducting and store these various values in the form of some kind of a file or a database for us to retrieve at a later point in time. So that is one thing that we are going to look at. And subsequently, how do we deploy this kind of a application in in the form of a web service API using Python, Flask, and such other tools? So in order to get a strong understanding of this, I will request Harsh Karry, who is my colleague at Capgemini, a machine learning specialist, who will actually demonstrate with the example of a model that has been created. This model is primarily one where we are trying to figure out whether a person is likely to repay a loan or not. So we want to find out whether we can give a loan to this person based on the fact that this person is likely to repay his loan or not. And therefore, we give certain parameters like his income, his date of birth, and his tax returns and such details. And we are able to make a prediction of whether he is likely to repay his loan or not. This will enable us to achieve a decision on whether we have to give him a loan or not. So with this particular example of a loan repayment type of a model, I am going to request Harsh to start sharing his screen and take us through this journey of how we can use some of these tools in the context of ML ops and ML engineering. Harsh?
Yes, sir. Thank you. Yes, let me share my screen. Please let me know if you can see my screen.
Yes, we can see your screen. Put it in projection mode.
Just we can put it on full screen. Presenter.
Okay, is it fine?
Perfect.
Yeah. So, hello everyone. This is Harsh. I'm working as a machine learning engineer in Capgemini under AI MLCO, where we'll provide NLP and machine learning based solutions to the business. And so today I'm going to demonstrate few products where we are fall upon once we are trying to develop a business use case and complete it and provide it as a solution to the customer. Okay. So let's start with ML flow. So what is an ML flow? So basically, I'll start with why we need ML flow, right? So initially, let's just for an example, let's say you're working on some use case and you want to iterate on multiple experiments, and I try to find out which particular experiment did well and how you are going to find out based on your evaluation metrics, right? So there is some interconnectivity based on which based on evaluation metrics, what are the parameters you are having, and which model performed well, and what type of features actually performed well. So what type of data is required for respect to that. So all these details are really tedious to capture in a Excel sheet. So let's say you are working and it's not scalable. Let's say if in an organization where you're working with 4 to 5 data scientists, and each one is working with their type of algorithms and trying to find out which is the best model based on their iteration. So handling everything in a CSV format file or in a sheet or kind of, it's not scalable. First of all, it's a tedious job. So to solve this problem, Databricks has open source their one of their solution called ML Flow. So this ML Flow is an open source solution. I won't go with slides much. I'm more into hands-on. So I'll just start doing with some things like here. So this is an ML flow logs. So as you can see at URL. So you can see here this ML flow is an open source solution which can be used on any of your data science project. It's just like a pip install ML flow and you are good to go with ML flow. Okay. So I'm just starting with a demonstration where I just as discussed by Dr. Prasad, like what is the problem statement we are going to solve. Here I'm not going upon how we are going to solve this, what features we did, and what type of algorithms we are using for this. Main focus of for this session is how MLflow works with respect to tracking your experiments and how we are going to productionize once we have developed an algorithm. Okay, so you can see I have imported some libraries, and I will also captured which version it is. Even I'm also have data for which we can use. I will also share the GitHub link where you can get these notebooks and codes and try on yourself, with yourself. So I have loaded the data set. Okay, so you can see there are 45 features for which I have to predict whether that particular person will default a loan or not. Okay. So here the main part starts. It's called tracking the application. So basically, just for an assumption, like what type of things we have to track. Okay. So this application provides us two components actually, which will help us to track whole experiment or iteration, whatever you want to say. Okay. The first component is tracking metadata. So what are the metadata? metadata can be your evaluation metrics. What is the accuracy? What is the F1 score? What is the AUC curve based on your evaluation metrics? What type of things here is there? And even what are the parameters? Who trained this model? At what time this particular model got trained? Okay, what is the version of this model? This parameter, this type of metadata are really crucial when you are doing multiple iteration and you are working in a scale. To store such type of data, we have ML Flow has a capability to store this data into a database. You can select based on your request, like based on your what you want to do. It's like MySQL is a database, MS SQL, SQLite, PostgreSQL. So these are different type of database which you can connect using SQL Alchemy database. Okay, so to run this experiment, I did it locally, so that we don't have to fall with some dependency with some database. So SQLite is an open Python open source database which we can use. And similarly, we have more thing called artifact storage. Okay, so the second point component which solve other problems are, once the model is got trained, okay, and it's having that weight file, right? So we have some feature, we have to store that feature Excel sheet. We want to store some images with respect to that, so where we have to store it. So MLflow also give us a capability to store our artifacts. So what type of repositories where we can store our artifacts? The first one is Amazon S3, Azure Blob, it can be a Google Cloud, or even you can store it in your local disk. Okay, so for this session, I have specifically used this architecture where I'm storing all my data into mlrun.db, which is an SQLite DB, and I'm storing all my iteration, whatever experiments I'm doing, into a folder structure inside my local machine only. Okay, so I'll just show you how this data is getting stored. Okay, I'm just first of all, let's start this application. So as I said, this is an server-based service which we are trying to use, and we want to analyze this, right? So even I have mentioned that storing this and analyzing this data into a sheet is really tedious. I will show you how we can do this and get a UI out of it. Okay, so this is my development ID. I'll just go through it, and let's say where I'm. So I'm going to demo this. I'm having we call this here. I just want to host this. I'll just paste this. Okay, so once I paste this and I run it, see what happened. That time I'll just come here and I'll show you what it is. So MLflow, as I talked about two components, one is storing the artifacts and other one is storing the metadata. So here you can see I am defining where I want to store my artifacts. So I'm saying that store my artifact into an SQLite DB, which is called mlflow.db. Okay, and similarly, I'm saying where I want to store my iterations, what type of iteration, number of iteration, which will capture all my metadata and other details, such as typical file or HDF file if you are working with deep learning model. I'm saying I want to host this application is in my local host this and in this particular port. Again, come back and you can see it started hosting a service. Once I click this, and again go back to my browser, you can see it automatically opened a UI for me. Start. Let me host in some other port. Maybe the port is the issue. I'll just close this, Control C. And open a new one. about it. Is this URL again?
So while Harsh is bringing up the actual MLflow UI, we want to reinforce this concept that there are experiments that you will run in order to get the actual information about what are those parameters that you have changed and what was the accuracy that you got, what was the F1 score, and such other details. Now, MLflow is one such open source tools which enables you to visualize all of these experiments in a single place. And it looks like the UI has now come up. Harsh, back to you.
Just a second. So I'll just go to the place where I kept my DB so that we can see some experiments too. Just okay. So our UI is up. So you can see I did some experiments. I'll go through these experiments. So the basic point here is just to go through this how we are going to use this. So as I can see, I have started my application. Now this is now I can able to track my notebook iteration with this application. So as you can see here, I have tracking this on 5001. I have to just change this particular port. So on which server UI and which IP you are tracking this, we have to provide the correct details. Okay, so here this is the detail. Okay, once you did that, the basic steps what we do for our training, testing, and all the algorithm building steps. So I'm just skimming through all this activities. So what we have to train, test, build, and we have to handle our missing values, and then we have to convert our numerical some feature which is actually numerical, and even have to develop some new feature out of some one feature. So this type of activities that we are doing. So you can see here what I'm doing is, once I did everything, I'm also capturing what type of feature engineering or feature handling I am doing. Okay, this is really important. Once we are trying to take this code from notebook to a production, okay, because in production you have to provide the details which has been trained on whatever algorithms you have used. Okay, so with this type of thing, so we have to also you have to keep in mind that you have to capture these details. So what all dictionaries you have used, what is the mean. So you can see here, I'm also handling the categorical values, and also what is the missing values, is there any missing values, and even the numerical values. So let's say some numerical missing, this are missing, I'm capturing that, and what is the mean for that particular feature, I'm also capturing it into a pixel file, so that I can move this data to production and I can use this type of data. Okay, and also some rare values, I'm also capturing what type of rare values are there, what all type of details are there. Even I'm checking whether how I can encode this, if there is a categorical value, what type of category it is, and what type of categorical numerical category I have provided to it, and even I'm saving it as an artifact. Now coming to that experiment part, how all these details, whatever feature engineering, what type of categorical missing value, what all things we added. So we did it right now. Okay? So but now we have to track this for each application. We need to track all these systems, right? So I'm now coming back and I'm just zooming somewhat my screen so that you can able to see these things, what MLflow is capable of doing. Okay, so here is a basic diagram of what type of APIs MLflow provide to capture all these details. Okay, so as I can see in my in this detail, you can see there's one MLflow log parameter. So what all parameters are there? This can be a learning rate, or it can be which type of model, other model related parameters it required. We can track this. When we want to track the metrics, and with using MLflow log metrics, kind of your AUC or F1 score with respect to this parameter, what it's generating. Even you can set some tags, let's say which version of iteration you are doing, it's a V1 or V2 or V3 version, or what type of application. So some kind of information you want to provide as a description to while you're experiments. Okay, so all these three types of details are going to store in our first component. So what was our first component? It's a DB. So we are having a DB where we are storing all this metadata, right? Similarly, other three, it's coming back to other three, it's able to store our log model. So let's say we are using a Keras model. So we are using sometimes a TensorFlow model. We are using sklearn model. So there are multiple models. So MLflow is capable of tracking what type of models you are using. It can able to track it. Okay, just by providing mlflow.keras.log model, or for Keras for sklearn, if you want, you can write this sklearn and it will directly track that model and save it. Okay. Similarly, we can store artifacts. Let's say for every time you are doing some validation, you are creating some graphs, you're creating some heat maps, you are creating some feature values. You're creating some CSV format, CSV file out of it. So these are some sort of artifacts which you want to store. So type of details also you can store in this artifacts. And what is the Python environment? So one more the crucial part where we actually face problem is environment. Right? So let's say a data scientist A is just developed something in Python 3.8, and he did this application part and creation part, experimentation part, and provide the model to the machine learning engineer B and say that, okay, deploy it. And now machine learning engineer B is having a environment of Python 3.7. So there is a maximum chances that this type of things will break the code, because the version of the things in which it got trained is different, and the version of thing which is being used for productionization is different. So this type of details also we have to capture, and MLflow also help us to capture all these dependencies. Okay, so you can see this all this details can be stored in our component B, which is our artifact section, which can be a Azure S3 and a local or anything. It can be stored in cloud. Okay, so again I'll just zoom out somewhat. Okay. So now I'll just walk you through what I showed you in my diagram into a more Pythonic way how we can do it. So let's say I'm having an experiment where I'm passing the parameters to the model, and I'm saying I'm using a light BGM model. And here I'm saying that, okay, this is my model and this is the description of the model. So every time whenever an iteration happens, I want to point a description to that model. So what is the use case which we are trying to solve? Okay. And here you can see the tags. Here, whatever tags I'm giving, it's saying application don't default release. What release it is release 1 or release 2. So we are doing continuous model deployment and training and deployment. So it's coming into a version. So having a track of version, which version of model is we are building out, experiment we are doing, is also an important point which we can handle using tags. Similarly, as I told, we can store some artifacts. So a Python environment. Environment variables, we can store requirement.txt. So data scientist will provide a Pythonic, he can provide a requirement.txt and he can directly use it. Okay. So similarly, we have also whatever logs which we are having, it's like feature engineering related part or whatever we did. So we are also tracking that, so that once this model has been created, the same set of details can be passed on to the other side where machine learning engine will productionize this. Okay. So also I'm tracking this. I'm also tracking the parameters. Even there is a API for tracking the metrics. You can see. Once I run this and start my training, here I'm using some sort of hyperparameter tuning package, which will do some 10 iteration of training with multiple parameters. So here the learning rate ranges from this to this, so that we can have multiple set of iteration which we can use to compare. Okay, so say I did some 10 trainings and we can find this is the best score I got with respect to whole training session. And once I completed this training, now come the analysis to find out which model is good for production. Okay, so you can see this is the UI which I have started, and there are two experiments. One is MLflow default. So whatever experiments you have initially tracked in your kept in your notebook, it will take that experiment name, and based on that it will create a new experiment name in your UI. Okay, so I am having this experiment, I'm having this experiment. Okay, so let's start with this. So here you can see I did 10 iteration. All these 10 iterations are there. So whatever things it's capturing, at what time this particular iteration happened, what is the run, who has this iteration, where this particular source code is present, what type of model it's created, what all parameters are there, like what all parameters it's been used for training. I mean, these are the various parameters. So this learning rate, this learning rate, this learning rate, and so on. Okay, and even it's capturing the metrics, like with this parameter, what type of validation matrix, AUC matrix it got, and what type of F1 score it got. So likewise, you can even visualize this. Okay, even if you want to compare things, let's say I want to compare all models, what all this iteration has provided us. Okay, you can see it's also provide a comparative view where we can see that, okay, this is the comparison between all this model. Even you can compare this based on the parameters. Let's say I'm trying to compare this with learning rate with respect to validation AUC. So you can see this, right? You can understand, okay, even you can analyze this and understand, okay, with respect, my learning rate is high, actually my validation score is getting better. So based on this, you can even have a basic understanding. With this type of data set, I have to work on some parameter which is high, and we can based on that I can get better results. Similarly, based on other iteration, it's also provide a parallel coordinate plot where you can check with what different type of parameters, how this particular model performs. So I'm just removing few static parameters, let's say this, and you can see here. So learning rate is high. When the learning rate is high, it's always providing a better AUC curve. So it's like kind of we can increase our learning rate capabilities, and we can find out which set of parameters work well, and even try to increase our model. Okay. Now again, coming back to experiments, let's come back to an experiment and say that, okay, this is all what I got, and now I want to productionize this. Okay, so to do this, let's say let's shortlist it based on the parameters and find out which AUC curve is good. So here you can see the best AUC curve is 90. Okay, so this is, let's say this, so it will say that, okay, this parameters combination is good, which provide me a better accuracy, and I can directly select this. Okay. Now most of the part of the data scientist work will stop here, where he will identify a challenging model and say that, okay, this model is good, and you can see every iteration is capturing whatever things I have been given, frequent label, files of all this, even the images, let's say the graphs and all, and the requirement.txt, what all requirements are there, and even the graph AUC, what it is, how these metrics are trained, everything with respect to that specific, the confusion metrics with respect to that, even it's having the model. Okay, so even MLflow provide us a capability, and even it suggests a recommended way to, if you want to predict something directly in a notebook, you can directly snip this code and keep it in your notebook, and you can directly predict it with respect to a data frame. Okay, so this type of capability is also there. Let's say now you are sure that, okay, this model is fine, and I want to keep it in production. So here you can see a model registry session. So now once you are working in an organizational way where we have to develop something, so we have to track all this development. Tracking of your experiment is done. Now what? So now tracking of model, because once you are developing something in a business use case, and you have to continuously develop new model, and that model will go into production, and you have to the next run you will build some better model, and you have to productionize. So tracking of model which is in production, which is in staging, which has been in developing stage, is also crucial, so that we can understand, okay, this is something which is in production, and we have to remove it from this part, and we have to provide this. And even you can roll back your solutions also with respect to this. Okay, so let's register this model, and I'll say that this one more model is present. This loan prediction model. I can create a new model. There is one model already present. So I'll just select this and I'll say register. So once I register this, so you can see there is one version detail is came that okay, this model got registered at this particular time. Okay, now this model got registered, and now here you can come and you can see okay, whatever model you have registered, it's in this particular UI. So there were two versions. So initially I had one version and I kept it in staging, so that staging is let's just understand what is staging. So once you have developed something, it's in no stage, none stage. From there, once you say that okay, this model is good and we want to put a productionize it. Okay, so then the second part comes in where machine learning engineer will take this model and create it into a web service or some kind of application in the staging stage, and will develop it, and then we will push it this from staging to production. Okay, so now right now let's say this model is good, and I'll just select this model and say that okay, this I can use this model and keep it in staging. Let's say staged. Okay, now this is in staging stage. The version 2 model is in staging stage. So let's say now my as a data scientist work part is over. I am good with this model. I have completed some analysis, and based on that I created one model, and you can see here once I did it. So here one icon came, right? So once as a machine learning engineer, I come into picture, and again I open this UI and check which model is actually being selected. Okay, you can see here this this particular icon states that okay, there is one model which is a good candidate for productionization, and I can even check the accuracy and validate okay, this model is good or not, and based on that I can say that okay, this is fine. Whatever model I selected is providing a good result, and I can use this model. Here you can see this, even there are two versions, right? So both experiments I have kept it, and this model is performing well and it's providing an HUE of this. Okay, so now I got this model. Okay, again I go back to that particular version and say that okay, this is it, and this automatically archive the other model because it's in staging stage. Okay, so now I go to that version and I want to find out the source code which I want to use it. Okay, so you can see it automatically opens this particular page where my actual model details are there. It's particular parameters, it's evaluation metrics, but I'm not interested on these things. But I'm directly going to this particular model and open this, identify that okay, this particular model is present in this particular unique ID. So each time whenever an iteration happens, it will create a unique ID, and under that it will create a package of it. Okay, so I'm just showing you in local repository. Let's say we are considering it's a local repository where this data is kept. Okay, so here it's in notebook, it's in ML flow. Let's say this is one, right? 00A7A. Let's say check that 007A. So I think this one was the correct iteration. I can go inside this artifacts and take all these details, even the models, and I can push it. So currently I'm doing it manually. But what basically I'm going to do here is I'll show you my ID. So this is my ID where I'm going to demonstrate how to create a Flask application for productionization. Okay. So let's start. So here, basically, I just give a small glimpse. First of all, don't worry about what architecture it is, how I'm doing it. I just want to try to connect the dots of this ML model. Here I'm storing my ML model artifacts. Under this artifacts, what I will do, I'll just manually move all this data which is present here to this particular folder. Okay. So now first part is over, where data scientist provided in the model and it's in staging stage. Now I'll come into picture and I'll start working on creating this model. Okay. So just a second. So basically in this session, I won't go on coding part. I will how I coded this, what type of scripts I used, how this, what is the flow. But mainly this will be more on the structure, how to structure your project so that you can productionize it. For this particular application, I have followed this structure where I will go one by one on each folder, what type of details it's carrying, and why it's kept in such a way so that you can understand, okay, this is required. And even you can even understand by the Dr. Prasad's slide where he has showed you the 5% of the code is just ML code, and the other relative part where we have to do data validation, data verification, data feature engineering, all these details is really required at this point. Okay, so let's start. I will just show you how I'm able to do this. So here is a basic first step. It's called apps. In this apps, you can see I'm having a script called ML app. So this is my base app, basic script actually, which has been used as to start my application. Okay, so here with this app, once I trigger this application, my application will start acting as a Flask web service. Okay, so basically we have used object-oriented class. So this is actually recommended when you are working in developing a productionized and industrial solution, because code reusability and maintenance is really efficient when you are working coming from procedural to OOPS concept type of coding. Okay, now I'm going to configuration. So here I'm having multiple configurations. Okay, so why these configurations are required? Okay? So even again going back to Dr. Prasad's slide where you saw a configuration set, where what it actually meant is, once we are developing something and we want to provide the solution, so we don't want to do this code changes every time. Okay, so changing code every time it's very high maintenance, and it's even there is a high chances that particular code will get break. So we will try to minimize this thing by changing everything in a configurational way. Okay, so here I'm using a ML config. So this what this type, what it contains. So you can see here in this ML conf, what I'm saying is I want to say that, okay, this is the folder where my application will store its data. Here it will store its logs. So the monitoring part, where whatever data which it's coming, it will application will monitor what type of HTTP protocol is coming and what type of data is coming, where it getting crashed and what time it got crashed. All these details can be logged in a log file. This is actually crucial when you are working on a big application, because this will actually provide a better understanding how your application and the model is performing in real world. Okay, so why we are doing this in configurational way? First of all, so let's say this is in my local desktop, and now I want to put this in some sort of OS in Linux machine or in some Windows machine or some cloud machine. And each machines have their own folder structure. Each customer have their own folder structure, or they want to deploy this type of application in some sort of particular directory, right? So to minimize the changes in code level, what we can do, we can whatever changes it required, where based on the OS where we are trying to deploy, it will change that similar things here itself. So changing here will automatically replicate to the whole application and start working in that. Okay, similarly we can store our application data into a database. So it's also having a connectivity. We can also connect our application to database with respect to SQL alchemy. It's also Python. It's also a Pythonic package which we can use to connect it. But in this particular session, I'm not showing it. And so likewise, we have some server configuration where you can work on this, and we can provide the host port and all the URL details on where you want to host it, and all this configuration where the model it is. The controller section, by the name controller, you can say that it will control the whole application. So from which request, where all this request should go. So in this base controller will control the HTTP protocols. If I'm hitting this URL, hello URL, it should go to hello world application. And if I'm hitting to this lone defaulter URL, it should go to lone defaulter and it should do its work. Okay. Likewise, we have some other folder structure which will help us to control this application. This is also one thing which is required to control the configurational parts, and we can configure our database here. This is the ML model configuration, which I already showed you how I pulled all that model pickle files and model edited files from there and stored it here. And here is the default predict file. So this is basically what we did in Notebook. So it's just kind of calling all these functions in a file in a structured manner, and whatever feature selection and feature processing we did in our code, in the notebook. Same things we had did in a productionized way, and we have followed some basic standards of try and exception block so that we can log some type of issues, because it's really important, because once we are doing it and some sort of wrong information, some wrong data came, it will directly crash our application. So this type of exceptional building of handling is also required once we are working in such type of big application. And even we have a utils function where we can store some data with respect to some sort of Python's some sort of definitions, Python definition which we can regularly use. Okay, so code reproducibility is increased. Okay, so this is how this application looks like. Now I'll just start my application. So here you can see this is my main file. I can start my application, and I'll just start my application. Okay, you can see this, my application is getting started. As this application is getting started, I'm just going to show you one more application. It's called Postman. So Postman is one wonderful open source software which we can use to test our REST API. So whatever things which we are doing is through a REST API, where we are passing some data from front end, and this data is being provided to back in the web service which we have created, and based on that it will react. Okay, so we have created two signatures. One, as you can see, it's got started. It's actually starting. And I have created two application, two signature. One is hello world. Let's see, and if I post this, see what happens. Send. Okay, so as I send hello, it gave me a reply called hello world. Okay, this is some basic application. I just want to show how these things work. And similarly, I'm having a feature, a set of features. So the real world feature, which I'm saying that where all these features are being part of my application. I'll send this data, and based on this, it will go to my backend application which I created. It's saying that prediction is 0, so that the person won't default the load. And here you can see this thing that here I'm also capturing the different type of build, how this application is working. So yep, based on this session, this is what I want to show. If you like it.
Excellent. Thank you, Harsh.
Yep.
So hopefully all of you got a view of how ML, model development, and actual machine learning is a small component in the overall concept of ML engineering. ML Flow is one such tool which enables us to automate or actually track many of those activities which we would do in the context of ML engineering. And you need to have a very clear structure in order to deploy your code in the form of a API, so that code becomes reusable, it is robust, and configuration files are used in order to change parameters. That way you don't make code changes and your code remains intact all the time. And that is the clear industrialized approach to developing ML engineering type of applications. With that, what I will also try and do is to try and see if there are any questions that have come up on this Excel sheet that has been shared with you. So there is one question from Iona Bhaduri, which says, can machine learning help in enhancing online education? In fact, the applications of machine learning are only limited to your imagination. As long as you have data that can be used in order to learn or create some models, and that model can be used for predicting some future behavior, you can use machine learning in that context also. As an example, in the context of online education, if I were to think of a use case of how machine learning can be used, it would be a situation where, based on the performance of students in their periodic tests or something like that, can I discover which of those students in an online kind of a environment are truly needing more help, and where this online mechanism is not actually helping out. So that kind of a mechanism of discovering those people who need more assistance can be one example of how machine learning can enhance online education. It can also be used to discover content that is of greater value to the audience and be able to predict that, okay, these are the kinds of content that will be of greater value. There is a second question here which says, can the Jupyter notebook be shared? And in fact, I would request Harsh to share the slide where he has kept all of this code in a GitHub this thing. So Harsh, can you please share that slide where you have that GitHub repository where this entire thing has been shared? So any of you can actually refer to that code and use it in your these things. Aditya says practical session is amazing. We would like to have more of these. Certainly, we would work with IIT Madras and figure out how we can help you further in such practical sessions. Harsh says, is that machine learning only useful in data sciences? Well, machine learning is one area that enables us to create models using data as your input. So where you do not have the capability of creating a program from first principles, machine learning based programs enable you to achieve that in a much shorter time. As an example, if I ask you to write a program to recognize my face, clearly the amount of code that you will have to write to recognize one person's face will be quite humongous. And then having written that, if you have to write the code for somebody else's face recognition, that would also require a significant amount of time. On the other hand, by providing data of my image to a program and being able to discover those features from my face and being able to recognize further features is a specific activity that will enable us to achieve that same result in a much faster, better, cheaper manner. So again, the answer is machine learning is useful because it is a data-driven model development approach, and therefore it is found to be of great value in the context of data science. But machine learning is only a technology enabler. It can be used in the context of retail, it can be used in insurance, it can be used in banking, finance. All of the industry sectors that we are aware of can use it. Okay, can you briefly, so Annapurni says, can you briefly explain what is the ML life cycle? In fact, this slide that we just shared a few minutes back, in fact, early on in the session, that is where this entire ML life cycle has been explained. So I would request you to go back and check what is the complete ML life cycle. Manan Tilwani says, how ML models will be useful for common people in their day-to-day life in future as the development of ML is taking place. So as a very trivial example, today we have a mechanism of interacting with computers through a keyboard, and some of these machine learning and AI algorithms have enabled us to have a conversational user interface with the machines. What I mean by a conversational user interface is all of you are probably aware of how Alexa, Siri, Google Assistant are all capable of taking voice inputs and creating certain outputs. Therefore, the ability to interface with a machine through a keyboard is not anymore needed. And in the context of a large country like India, where the penetration of computers is also not very high, and more importantly, people who know how to use keyboards and have the facility of the Indian language is also pretty low. If you enable them to actually interact with the computer with a conversational user interface, you will find the adoption of these to go up very dramatically. And that is also the reason why e-commerce sites, whether it is from Amazon and Flipkart and things like that, have started localizing the language and have also started providing speech recognition based conversational user interfaces for you. So these are all examples of how common people in their day-to-day life will use machine learning and AI in the context of their work. How can we start machine learning? So this is Ashish Jain who says, how can we start machine learning as a beginner from scratch, I'm sure you can enroll in any of these online programs, and you will be able to become a good machine learning engineer. Last question, it is about 6:59. So what is the integral solution that can maximize the designing of the model to address the actual need of the client and can give 90% customization? I'm not so sure if I understood that question. So I will pass that. If you can simplify the question and write to us, we would be happy to answer that. Then there is a question says, where to start learning machine learning from books, courses? Yes, there are a whole bunch of online courses. IIT Madras has got this online course also. Please enroll in one of these courses, which will help you in learning this. There is a question from Devops who says, can we differentiate between data drift and model drift, which is important? This is actually a very hardcore machine learning question, and you're really asking whether there is bias in data or whether the model itself has changed over a period of time. And whether there is bias in data is something that you can easily identify by comparing the statistics of your current data with the data that you use for training, and that will help you identify data drift. That is a fairly simple statistical technique that you would be learning as part of your machine learning courses. And very last question, right on the hour, how to tackle large error or gap in the results of ML prediction or results. So if you are getting a huge amount of error, it usually points to the fact that you have not trained your model correctly, and therefore it may require certain tuning of your hyperparameters. It may require more data for training. There may be, I don't think there is a single answer that can be given to this question, but with experience you will understand how to handle these kinds of situations. So we are exactly at the top of the hour, and with that I will thank all of you, and hopefully this was a session that will enable you to industrially deliver some of your applications and gain from this kind of a session. Thank you all.
There are a few questions in chat window also.
Well, we are past the hour, and therefore I don't think we will be able to answer that. People who want to ask questions can definitely reach out to us directly, and we will be more than happy to answer those questions. Yeah. Okay. Thanks a lot, guys.
Thank you, sir. Thank you so much, sir. Thanks for the session. Wonderful.